Hello, a very good evening. Today, I explain you continuity and differentiability for class 12. It's very important chapter as it consists around 10 to 15 marks from your examination point of view. So, let's just start it. Introduction of continuity is a general algorithm. It is just animation. So here it is general x and y graph on a random plane. So we have to say that y is equals to fx is a function which lie on this graph. Here it is point P and we name it A and it is B or whatever what you want to say. It's totally up to you. Okay, so start in this curve. Okay, in this curve, this curve, y is equals to fx is a function. We see that the point P has the x coordinates of a and the y coordinates of fx. Now what happens if limiting values from left hand side means from this side? Okay, and the limiting value from the right hand side tends to f is equals to a. Here the left hand limit LHL is equals to RHL. Okay, so on in the other words, limit x tends to a minus. Okay, so it means fx. Okay, so it means the function value fx tends to which value? I mean it is very close to a. Suppose if we from here this yellow dotted line from point P to point B. So from the left hand side it tends to point P. So this one is known as LHL, means left hand limit. Same as from the right hand limit if it tends to point FA. Okay, very close to FA. Then this one again is tends to this one. So we take it FA. So we note it down, limit x tends to a plus fx, which is RHL, means right hand limit. And here we see that the function at point P, it itself is a. So it is also equals to fx. So from this we conclude that left hand limit and the right hand limit and the function itself are equal. If these three parameters are equal, then the function is continuous at the given point, means x equals to a. Okay, I hope this one is clear to you. Again, continuity. Basically, we say that the function is continuous at a fixed point. If we can draw a graph of function around without lifting a pen, then the plane of the paper, so the graph is continuous. Suppose here x and y, a graph, and I make this. So I make from a line from A to B without lifting my point. So this graph is continuous. Okay. So in this graph, fx is equals to 1 if x is not equals to 0 and fx equals to 2 if x is equals to 0. So here we say when fx equals to 1, okay, fx equals to 1, this one, this. Okay. Then what is y? Y is equals to also 1. So y is this 1. Again, if x equals to 2, then y is here 0 comma 2. If we make a line from point A to O and B to O, if we wanna graph this function on x and y, so firstly we have to draw a line from A to O. Then we have to draw a line from B to O. Okay, so it is not in continuous because firstly we draw A to O and we lift our pointer, again we draw B to A. So this function is not in continuous. What is the definition of continuous? Suppose f is a real function on a subset of real numbers and C be a point on the domain of f, just continuous at C. If we can write it mathematically that limit x tends to c fx equals to c, when if we find the left hand limit and again we find right hand limit and the value of the function means fx itself equals to c exist and equal to each other, then f is said to be continuous at the given point x equals to c. And one more very important thing, if the function is not defined means infinity, then function is discontinuous at the given point. It never be continuous at the given point. So let's take an example. So here the function is given 4x square minus 12x minus 1 upon 2x minus 1 is continuous or not at x equals to 1 by 2. So firstly we write it 4x square minus 12x square minus 1 upon 2x minus 1. If we put x equals to 1 by 2 in above equation, so firstly we check denominator. 2 into 1 by 2 minus 1. After cutting this, we get 1 minus 1, which means equals to 0. So here 0 comes in the denominator, which means the function is not defined. So the given function is discontinuous at x equals to 1 by 2. Okay, I hope it clear to you. Differentiability. Okay, so here f dash c is equals to limit x tends to a f x minus f a x upon x minus a. So you're thinking why we consider this? Okay, so now just try to understand one thing. We have to calculate that the limit means RHL, right hand limit on the limit means right hand derivative and left hand limit of the limit means left hand derivative. Okay, so left hand we know that limit x tends to a fx minus fa upon x minus a is the left hand limit, and same we write it RHL, right hand limit. Okay, so in the above notation here, okay, we put x equals to what? We put x equals to a plus h in everywhere, means here and here also. So see, limit h tends to o f a plus h minus f a upon a plus h minus a. After solving this limit, h tends to infinity in 0, sorry 0, f a plus h minus fa upon h. So this is known as what? Right hand derivative of the function. Same as for the LHL means left hand limit, we put x equals to what? A minus h. Here we put x equals to a minus h. Okay, because it is left hand limit. Then limit h tends to 0 f a minus h minus f a upon a minus h minus a. After solving this, we get limit h tends to 0 f a minus h minus f a upon minus h, which is left hand derivative of the function. So here we conclude that a function is differentiable if this limit exists finite. If the limit is infinity, then function here The definition of differentiability. A function is said to be differentiable at x equals to a if left hand derivative is equals to right hand derivative is equals to finite value. And on previous we find it what is left hand derivative, what is right hand derivative, and what is finite value. So note it down. Limit h tends to 0. uh, Let me erase it. H tends to 0 f a minus h minus fa upon minus h. This is left hand derivative is equals to right hand derivative means limit h tends to 0 f a plus h minus fa upon h. This is right hand derivative. So here left hand derivative, right hand derivative, if these two terms are equals to finite value, then the given function is said to be differentiable. So here firstly before taking example we have to know what is the relation between continuity and the differentiability. So in very simple language, a function is continuous at a given point. It's not necessary that this function is differentiable also at the given point. Okay, but if a function is differentiable at given point, then it must be continuous at given point. So differentiability implies continuity, but continuity does not imply differentiability. I hope it clears to you. So let's take an example now. Here we consider a function fx equals to 2x minus 3 power 1 by 5, this one, and at the point x equals to 3 by 2. So for checking the continuity, the left hand limit and the right hand limit and the value of the function at x equals to a must be equal. If these values are not equal, then a function is not differentiable at the given point. So firstly we take LHL. LHL equals to limit x tends to a minus fx equals to limit x tends to 3 by 2 to x minus 3 power 1 by 5. If we put x equals to 3 by 2, so we cut it 2 and 2. So here we get what? 3 minus 3, which is 0. So this is what? 0 power 1 by 5. So 0 power, 0 power 1 by 5, which means it's equals to 0. So RHL is equals to limit x tends to a plus f x equals to limit x tends to 3 2x minus 3 power 1 by 5 equals to 2 into 3 by 2 minus 3 power 1 by 5. When we solve it, we get 3 minus 3 equals to 0 power 1 by 5, which means it itself 0. So here we conclude that LHL means left hand limit is equals to right hand limit equals to function itself, which these all three terms are equals to 0. Hence the function is continuous at about the point x equals to 3 by 2. So if function is continuous at the given point, then we have to check what? Differentiability. Okay, so start. For checking differentiability, we know that f dash a limit h tends to a f a plus h minus f a upon h. Limit h tends to 0 f 3 by 2 plus h minus 3 by 2 upon h. After solving this, yeah, 2 3 by 2 plus h minus 3 power 1 by 5 minus 2 3 by 2 minus 3 power 1 by 5. We get 3 plus h minus 3 power 1 by 5 and 3 minus 3 power 1 by 5. When we cut it, we get 0, and here h 1 by 5 upon h. So this is numerator. When it goes to denominator, then the sign of the power is changed. Then it be minus 1 by 5. So here h power 1 minus 1 by 5, which is equals to 4 by 5 h. So here we know that 1 upon h bar 4 by 5, and h tends to 0. So it be 1 by 0, which is equals to infinity. So the function is not differentiable at x equals to 3 by 2, because we know the function must be definite at the given point, but here the function is indefinite, so the function is not differentiable. So here we conclude that a function which is continuous at the given point, it not necessarily the function also differentiable at the point. Okay, I hope it clears to you. I summing up this topic. Thank you so much. I hope you enjoyed it.